Hello, hi everyone. Welcome to the Student the Brand. So this is Shiva sir. Today we are going to discuss electricity, electric current. So we will now discuss. So electric current is nothing but the rate of flow of charge. Electric current is nothing but the rate of flow of charge. There are two types of charges are there: positive charge and negative charge. So the charge of an electron is 1.6 into 10 power minus 16, 10 power minus 19 coulomb. So that is the value. So 1.6 into 10 power minus 19 coulomb. What is the value? Charge of an electron 1.6 into 10 power minus 19 coulomb. So that is the charge of an electron. And normally positive charge will repel each other. Positive charge, negative charge will attract each other. Okay. So charge is a property of the material which influences the other charges present around it. That is about charge. And the electric current. Coming to electric current, the rate of flow of charge. The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. I is current, Q is a charge, T is the time. So SI unit of current is ampere. I is nothing but current I said no. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So I equal to Q by S. So 1 ampere equal to 1 coulomb of charge flowing through 1 second. That is about electric current. Okay. So now here we can observe there are two types of current: positive current and negative current. So there is nothing but conventional current and electric current. So it's not about positive and negative, it's about conventional and electric current. Conventional current is nothing but the flow of positive charges. So the positive charges are moving. The positive charges are moving from positive terminal to negative terminal. So before finding electron, proton, neutron, electron, all these things, so they already given the statement. The statement is the flow of positive charges is considered as a electric current. So that is still we are using. That is still we are using for our convenience. That's why we are utilizing the statement as a current. So that's why we already know that after finding those things, we already know that the flow of electrons, because of the electrons movement only current will pass. After knowing this statement, so before already that statement are using, that's why we are using that statement as a conventional current. Conventional current. So after knowing these things, so we are using this statement as a electric current. That is conventional current, electric current. So what is a conventional current? The flow of positive charges. The flow of positive charges. What is the direction of conventional current? The direction of conventional current is the direction of flow of positive charges. So how the positive charges will move? Positive terminal to negative terminal. Positive terminal to negative terminal. How the electrons will move? Electrons will move from negative terminal to positive terminal. So that is about current, right? Now potential difference. What is the potential difference? Potential difference is nothing but the work done to bring unit positive charge from one point to another point within the conductor. The work done to bring unit positive charge from one point to another point within the conductor is called potential difference. SI unit of potential difference is volt. SI unit of potential difference is volt, V. So here we can observe SI unit of potential difference is at volt. Okay. So here one more definition is there. What is that? Electrical potential. So potential difference is nothing but the work done to bring unit positive charge from one point to another point, that is called potential difference. Electrical potential means the work done to bring unit positive charge from infinity to the required field, that is electrical potential. So both SI unit is same. Both SI unit is same. So volt only. Okay. So here potential difference, the work done to bring unit positive charge from one point to another point within the conductor. Within the conductor, if it happens, that is a potential difference. Whereas some point infinity to required field, that is a what we can say, that is nothing but electrical potential. So that we can say SI unit of potential difference is volt. And now we can see which device is used to measure the potential difference. Voltmeter. Voltmeter is used to measure the potential difference. And here a voltmeter will be connected parallel combination. Voltmeter will be connected in parallel combination because the potential difference will be across the wire, right? So we cannot connect in series. So there won't be any difference in electrical potential in series. So across the wire we have to connect, there is a potential difference. So voltmeter will be connected to the circuit across the wire. That is in the parallel combination. So coming to the electric current, whereas electric current is nothing but SI unit of electric current is ampere. So which device is used to measure the electric current? Ammeter. How the ammeter will be connected? Ammeter will be connected in series. So here you need to understand. So voltmeter cannot be connected in series. Ammeter cannot connect in parallel. Voltmeter must measure the potential difference. If you connect in series, there won't be any potential difference. It won't show any reading. Whereas ammeter cannot connect it in parallel combination because so ammeter has fixed reading. So if you connect in parallel combination, different appliances require different potential difference. So when the current is going more than required limit, then it's slightly getting heated. So that's why. So what happens? So the potential difference, voltmeter must be connected in parallel, ammeter must be connected in series. So that is about potential difference and current. Coming to Ohm's law. Ohm's law here, actually one more points are there. Like a cell is nothing but positive terminal, negative terminal, and battery. Two or more cells to be connected, and resistance. Resistor is a device which is used to oppose the electric current in this circuit. There is a resistance. Resistance is nothing but, so here you need to understand the resistance. What is the resistance? The phenomena of opposing the electric current in the circuit, that is called resistance. SI unit of resistance is ohm. What is the SI unit of resistance? Ohm. Okay. So now one more thing. Rheostat. The device which is used to regulate the current without changing the voltage source. So what is the rheostat? Rheostat is nothing but the device which is used to regulate the current. See, when you are taking the fan you can observe, you can regulate. So 3, 2, 3, 4, like that speed we can increase or decrease. But we are not changing the device. Without changing the device, we can regulate the current, how much our current is flowing to the fan. Okay, that we can use. That is rheostat. And next one, ammeter. Ammeter already we know. So ammeter is a device which is used to measure the electric current that will be connected in series to the circuit. Voltmeter. Voltmeter is nothing but it SI potential difference is volt. Voltmeter is a device which is used to measure the potential difference. Voltmeter will be connected parallel combination. That's okay. Okay. And next one, we can go through wire. So normal copper wires like that. Wire joining. So wire crossing. That's enough. There is a bulb, electrical bulb. So those are the electrical components. And coming to the Ohm's law. So the statement is very important. Ohm's law statement. Ohm's law, if you coming to the Ohm's law, the potential difference across a metallic wire is directly proportional to current flowing through it. That is nothing but Ohm's law. The potential difference across a metallic wire is directly proportional to current flowing through it. That is nothing but Ohm's law. V is directly proportional to I, V equal to IR. So here R is the resistance, R is the resistance, I is the current, V is the potential difference, R is the resistance, V equal to IR, V equal to IR. Okay, so that is about potential difference. And here ohmic conductors and non-ohmic conductor, 2 points will come. Coming to ohmic conductors, the substances which obey Ohm's law. The substances which obey Ohm's law are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. So for ohmic conductors, the graph is straight line. For non-ohmic conductors, the graph is not straight line. Okay, it will be curved. And the ohmic conductor, whatever the graph the ohmic conductor is, that is a linear. Start from 0. Okay, so ideal ammeter resistance is 0, ideal voltmeter resistance is infinity. Okay, ideal ammeter. Why ideal ammeter? Because it is not opposing, it is allowing everything, right? So resistance is 0. Ideal, see. So ideal conditions. So whereas resistance for a voltmeter is up to infinity, up to that much it should obey. So it should measure the potential difference. Ideal voltmeter. Okay, ideal conditions. And coming to the resistance is nothing but the phenomena of opposing the electric current in the circuit is called resistance. SI unit of resistance is ohm. Resistor is a device which is used to oppose the electric current in the circuit. So, and one more thing, we can also consider the it one resistance is directly proportional to length. Resistance is directly proportional to length. Resistance is inversely proportional to area. R is directly proportional to R is inversely proportional to area. R equal to rho into L by A. So RA by L, RA by L equal to resistivity. So what is the resistivity? Resistivity is equal to resistance of the conductor per unit length, per unit length. So RA by L per unit length and unit cross sectional area. Resistance of a conductor of unit length and unit cross sectional area. That is nothing but RA by L. Okay, so that we are talking about, that we are discussing about, that's why we are considering about. Okay, so good afternoon. That's enough. That is about resistance, and resistivity depends on temperature. Resistivity depends on temperature. Resistivity depends on hi Krutan, good afternoon. So resistivity depends on material of the conductor. Resistivity depends on material of the conductor also. Okay, next conductors. Wow, very nice. Very important topic. So conductors. Conductor means the substances which allow the electricity to pass through them. Those are called conductors. Okay, so metals will allow the current to pass through it. So non-conductors like say insulators, it does not allow the electricity to pass through it. Semiconductors means the substances which allow the electricity partially, those are called semiconductors. And here series combination, coming to series combination. Okay, so series and parallel, that will be different topic. So until the conductors, resistors, until conductors we're discussing today. So if you have any doubts, you can let me know. We'll discuss. So otherwise, in tomorrow class, we'll discuss about resistors are in series. Our next class, we can say next class resistors in series, resistors are in parallel. Next remaining topics. Okay. So until that one, see you. Bye bye. Thank you.